Hi students, welcome to the next topic from gravitations. Okay, we are almost approaching the end of these chapters and still there are few more important concepts has to be learned. So one of the next major concept is called escape velocity. Okay, so today's topic we are going to deal with about the topic called escape velocity. So write on the heading called escape velocity. Escape velocity. Escape velocity is representing using V suffix A. Different books are using again different notation. I have taken from Ncert textbook as standardized book. Escape velocity V. What is basically called escape velocity? Suppose I am standing on the surface of earth. I have a ball in my hand. I am standing in the surface of earth. I have a ball in my hand. I am throwing the ball. If the ball can go beyond the gravitational pull of earth, so which means the ball can escape out from the gravitational pull, which means if you have thrown something about a certain height, for example in two-dimensional motion you have learned about the projectile motions. You are throwing something and at maximum height it is returning back. So that is a context of discussion in 2D motion. So there is something you are throwing and something is coming back. But here this is a beyond the limit of that scope, which means you are throwing something and it's not at all coming back. It is going to a certain height, or we can say it is going to infinity, or we can say it is going out of the control of gravitational force. If you are able to throw certain ball or certain system or certain particles with that particular velocity and it is escaping from the gravitational pull of earth, then it is called escape velocity. Then the term is called escape velocity. So what is escape velocity? Escape velocity means the velocity, we can write the definition, the velocity at which the mass m, any mass you are throwing, the mass small letter m, going to infinity. Going to infinity means what? Going out of the control. So I'll say going out of gravitational pull. Going out of gravitational pull. Going out of gravitational pull. If you are throwing something and it's going out of gravitational pull means it is not returning back and it is going to infinity. So the point whatever we have discussing will be here, and which is going to infinity and it is not under the gravitational pull will be here. So the point will be here. So I have a earth of mass m. I have a small mass of m. I have a small, okay, let me put it as will be here. Have a of earth having a radius of r, for example, and from this radius of earth we are throwing something into infinity. I am throwing something, I am throwing with a velocity called ve, and this is going to infinity. So as I told in the previous session, in the previous class, we have two conditions will be here, right? If you look into your notebook, before the incident and after the incident. What is the before incident? The ball is at the surface of earth. This is before the incident. What is after the incident? It is going to infinity. So before the incident, which means the total energy will be here. And how I can do the total energy? Total energy is equal to what? Total energy at this point. So initial total energy is equal to total energy at infinity, because it's going to infinity. So what is the total energy will be here? I can say potential energy plus kinetic energy equal to potential energy plus kinetic energy, but total energy at infinity is equal to 0. Energy at infinity is equal to 0 because that is taken as a reference point. So everywhere we have some reference conditions will be there. Once you are drawing a graph, x-axis and y-axis, so origin is the reference point. So similarly, while calculating the energy, infinity is the reference point, there energy is equal to 0. Total energy is equal to 0. So which means these two factors together is also equal to 0. What is the potential energy will be? What is the expression for potential energy? Minus Gmm divided by R. R is the radius. This expression for potential energy of a mass m which is at a height of r meter away from the surface of earth. Plus kinetic energy half m v square. What is the velocity will be here? V e square equal to 0. Right side is equal to 0. So left side potential energy written here, kinetic energy written here. So these two together which is equal to 0, which means that what? I have to solve these equations in a simple way. So half into m into ve square is equal to, what is given? Minus Gmm divided by r. So take it to the right hand side. So it becomes Gmm divided by r. Small letter m got cancels. So what you will get? Ve is equal to root of 2 times of Gm divided by r. So r is the height. What is called r? R is the height. R is the height from earth center. From earth center. So r is the height from earth center. So we have to see what is r, and g is the universal gravitational constant, and g value already you know. What is the g value? 6.67 into 10 power of minus 11. Okay, so this value already know, and m is called the mass of earth. M is equal to mass of earth. Mass of earth. Okay, so these things we know. So this is expression for escape velocity. This is an important relation. So we will derive another set of equations. We know g is equal to gm divided by r square. Acceleration due to gravity we already learnt. So what is gm from here? Gm is equal to gr square. This we are substituting in this equation. So what should you will get? Ve is equal to root of 2 into, instead of gm you are substituting this. So you will get gr square whole divided by, in the denominator, r. So r square and r will get cancelled. So you will get root of 2gr. This is the another equations of escape velocity. So escape velocity will have two equations. V is equal to root of 2gm by r, or V is equal to root of 2gr. So both is representing what? So how we derived it? So when a ball will be here, from here I am throwing to infinity. Energy at infinity is 0. Energy here is equal to potential energy plus kinetic energy. Both energies are added, and we got this equations for escape velocity. Two equations, one is root of 2gm by r and one is equal to root of 2gr. So this is important. So again, what is escape velocity? The velocity at which the mass m going to infinity. So going out of the gravitational pull, because once it is thrown with a velocity called ve, it will never come back. Now we know we have these two equations. Both equations are same, one and the same. Now we know the value of g is equal to 9.8 meter per second square, and r is the radius of earth, 6400 kilometer. You can convert this into meter. So this is again equal to what? 6400 into 10 power 3 meter. If you substituted these values will be here into this equation, so you will get the approximate value as 11.2 kilometer per second. So this is important. So which means if you are throwing, so the value of g in this equation, g and r, g is the standard value 9.8, r is 6400 kilometer. So you can convert it to meter. You can substitute here root of 2 into 9.8 into r the value. If you substitute it, once you do that, you will get the value is equal to how much you will get? 11.2 kilometer per second. So 11.2 kilometer per second is the value of escape velocity where? On the surface of earth. When the distance changes, escape velocity also changes. That is a different story. But now our concentration, we are on the surface of earth. So once you are on the surface of earth, from there if you are throwing the mass m with a velocity 11.2 kilometer per second, is it possible for you to throw from here? Not possible for a human being to throw within 1 second 11.2 kilometer per second speed. if some system can send the mass from out of the surface of earth, then if it is traveling in 1 second 11.2 kilometer per second, that is very high speed. Kilometer in 1 second you have to go 11 kilometers. You can imagine 11.2 kilometer is how much distance. So that has to cover in 1 second. If you're throwing that much speed, then the ball will go to infinity. It will never come back to your hand again. So that is a concept behind escape velocity. So escape velocity, two equations. That is quite important to learn about the value of escape velocity at I can say different context. Okay, fine. So the value 11.2 kilometer per second, that is nothing but a standardized value, nothing to do with anything else. So we'll do a couple of questions again, as usual, topic related. Couple of questions we'll do, and then we'll see what is there and how we can solve that question, and whatever we have learned now is effective. Okay, fine. I hope you understood very clearly what is called escape velocity. If you are throwing a ball with a speed of 11.2 kilometer per hour, it will never come back to your hand again. It is going out of gravitational pull. Okay, next one example question. Next question is, if a body of mass m throws from the surface of earth, no, not from the surface of earth, okay, from a height h is equal to r is the radius of earth. If it is throwing at h is equal to r is the radius of earth, and the mass escapes from the gravitational pull. The mass escapes from the gravitational pull. In that case, what is the velocity? What is the velocity at h is equal to r? I hope the question is clear. If a body of mass m throws from a height h is equal to r, radius r is the radius of earth, the mass escapes from the gravitational pull. In that case, what is the value? What is the velocity at h is equal to r? So which means, the context of discussions, earth will have a radius r, and at a height h is equal to r, the ball is throwing to infinity. So the question is asking, I'll draw here to make it a better way. Okay, so let's have a mass will be here, earth, and at a height h is equal to r, I have a body of mass m will be here, and already the earth will have a radius equal to r, and this is throwing to infinity. So this is at a height of h, and it is throwing to infinity. So I can say total energy from where it is throwing from here is equal to total energy where it is reaching. This is starting point, this is ending point. So total energy is at infinity, both are same. Okay, so total energy at this point is equal to total energy at this point. So what is the total energy at this point? So I know total energy at infinity is equal to 0. So only left side exists, right side is 0. So we'll solve this one. So which means TEI is equal to 0. Potential energy initial plus kinetic energy initial is equal to 0. What is potential energy initial? Minus G mm divided by small letter r. I will tell you what is small letter r. Half m into VE square is equal to 0. What is small r? Small r is the height from the center of earth. R plus h. R plus h means r plus r. How much will come? G mm divided by 2r plus 1 by 2 into half into m VE square is equal to 0. Okay, so everywhere we have divided with m, so mv is getting cancels. So what's left now? here half VE square is equal to GM divided by 2R. Again 2 is also get cancels and you will get VE is equal to root of GM divided by R. So this is the value of, or not the value, this is the answer to this question. Okay, so VE is equal to root of GM by R. This is not the standard equation. Standard equations whatever we have learned before. This is with respect to this question. This is answer. That's all. Okay, do not miss the previous case and this case. In the previous cases standard equations which where we are throwing the ball or the object of mass m from the surface of earth. Here it's not from the surface of earth, we are throwing at a height h is equal to r from. So at that point what is the escape velocity? So that is the escape velocity root of gm by r. If you are throwing from the surface of earth, then the escape velocity is root of 2 gm by r. So be careful about it. Okay. Okay, super, great. Let's move to the next topic, or I can say like next concept kind of stuff over here. Fine, we'll do one more questions and we'll see. Then we'll move to the rest of this other areas. Okay, so let's clean this board first. So let's do this topic and then let's see what's we'll do one more questions, then we'll go around. Okay, so fine. Okay, we have here the next question. A body of mass m throws from the surface of earth. Acceleration due to gravity at h, at a height h, is g dash equal to g by 4. The escape velocity v is equal to v in root of n, where v is the velocity at which the body of mass m throws from the surface of earth. The value of n, question mark, the value of n. So what this question is speaking, I have a earth of mass m and this is throwing to an height of h will be is equal to r. So this is h is equal to r, I don't know, just saying at a height h. Okay, and this is reaches will be here. So at this point g dash will be equal to g by 4. So what is the initial condition? This is the initial condition. Total energy initial is equal to total energy final. Concept is clear. Okay, so but one hint is given, g dash equal to g by 4. H value is not given. In the previous question h value is given. H is equal to r, radius of earth, it's given, but here h value is not given. To find out h value, the g dash value is given. What is g dash? Gm divided by r plus h the whole square. This already we have seen, right? Acceleration due to gravity at a height h. Please go back to the notebook in case if you are not remembering. I told if it is a perfect square number like 4, 9, 16, 25, such cases are come, please use this square number on the right side. If such cases are not given, then use this equation 1 minus 2h by r. This will use if not a perfect square number. If this is a perfect square, so this is used when we have perfect square. When we have perfect square, this is a easy shortcut to remember. Okay, used when we have the perfect square. So g by 4, g by 9, g by 16, g by 25, g by 64, something like this one. This you can use when we don't have a perfect square. When we don't have, for example, g by 2, g by 3, g by 5, something is given, you can use this equation, that is easy to solve. But here is a perfect square, so we are using this one. So g dash is g by 4 is equal to, so we will use this equation, sir. And gm by, so gm divided by r square, take it out of this, so 1 plus h by r the whole square, h by r. So instead of capital H which is given, so I'll use capital H here also, capital H here also, h by r. So what is gm by r square? I know the equation, right? Gm by r square is called g. So g by 4 is equal to g divided by 1 plus h by r the whole square. G get cancelled, both the sides I'm taking square root. So 1 by 2 is equal to 1 plus h by r. So we'll cross multiply, 1 plus h by r is equal to 2, h will be equal to r. 2 minus 1 1 varum, then h is equal to r. So at a height we got the value of h is equal to r. So I need some space. Hope you have marked this, what can I say, the things, the question you have written. I'll clear this area. Okay, I'll clear this area because I need some space to answer the rest of the parts. So perfectly fine. So I find in the previous all questions the height is given, but here height is not given. Instead we have given an hint, g dash equal to g by 4. Now we have initial conditions and final condition. Total energy at initial is equal to total energy at final, and total energy at initial is equal to total energy where it's not infinity now, at a height called h. So here potential energy initial plus kinetic energy initial is equal to potential energy at height h plus kinetic energy at height h. So it is going and it is throwing to a maximum height of h at a maximum height. So it is going to the maximum height called h. Okay, beyond that it is not going. So that is a condition given. It is throwing from the surface of earth and it is going to an height of h, where the acceleration due to gravity g dash equal to g by 4. Then what is the potential energy at the surface? Minus g mm divided by r plus kinetic energy half mv square is equal to, v is the velocity they are told in the question, and at a height h minus g mm divided by r plus h, total height from the center, and kinetic energy at maximum height is equal to 0. So we'll solve this one. So small m everywhere got cancels. So we'll simplify. So minus gm divided by r plus v square by 2 is equal to minus gm divided by r plus h is equal to r, so it become 2r. Throughout I am multiplying with okay, this I'll take it to the right hand side. So v square by 2 is equal to you can simplify this, mathematical simplifications only, gm divided by r. So I'll got v square by 2 is equal to gm divided by 2r, 2 get cancels. So I'll got v is equal to root of gm divided by r. I got v is equal to root of gm by r. Now I'm clearing the lower part of the discussions what we have discussed so far. Pause the video and complete the notebook. Okay, notebook is mandatory. Okay, if you learn the notebook you will get all the theoretical questions whatever I am discussing. Okay, the question is in the question it is given ve is equal to v into root of n. What is the general equations for ve? Root of 2gm divided by r is equal to, what is v? V is equal to root of gm divided by r into root n. So by comparing these two, what is the value of root n will come? Root n. So root n is equal to root 2. So which means n is equal to 2. That is a question. So we answered the question. This is a little bit of work will be there in this question, because in the previous question the height h is given, but in this question the height h is not given. Instead of giving the height h, what they have done now, they have given g dash equal to g by 4. That has to use, and we have to find the value of h. That is the things in which we have calculated over here. Okay, fine. So let's move to the next part of the discussions. Okay, satellites. So escape velocity is over. We have done couple of problems. This session is very important for any entrance examination in which you are attending in general. So whether it is an engineering, whether it is a medical entrance examination, whether it is any science research oriented like kind of examination, for example like KVPY kind of examination. So wherever you go, this is important. So write out the next major heading on this topic called motion of satellites. Motion of satellites. Very important, motion of satellites. We are learning about like from our childhood onwards we are hearing about satellites are launching GSLV-3, GSLV-2. So satellites are launching by our very famous research center from Indian Space Research Organization, ISRO, is already doing that activity in a very well way, and there are a lot of attentions from the worldwide, like other countries are looking, like our science research centers are doing such an amazing work, and we are going to learn a very bit of that knowledge, something called motion of the satellites. So you know, satellites which are rotating around the earth and which will have a gravitational pull towards earth, then only it can perfectly rotating around the earth. So which means we have an earth of mass m will be here, and around this mass this is rotating with a certain velocity. So the satellite of mass I am considering as like m, and m is the satellite. Okay, satellite of mass m is considered, and this is earth. So there is a central force will be here. Okay, suppose I am assuming this height is very negligible height from this surface of earth, comparable to the radius of earth. The radius of earth is 6,400 kilometers, such a big size. Comparable to that the height will be negligible. If that is a context, or you can consider like anything, if you are considering like distance is very high, whatever. So okay, so in general I know the radius will be equal to r. This is a very small height h, but overall I am writing at small letter r, and this r will be equal to r plus the small height. So there is something will be there is a centripetal force will be here, and centripetal force will be equal to gravitational force. We have an attraction towards the center, so two bodies will attract, which means capital M, earth and satellite. What is the centripetal force? Because of this body, mv square divided by r. This is the velocity at which it is rotating. So this we call it as v0. V0 is called orbital velocity. V0 is called a very important term, which is called orbital velocity. So orbital velocity is the velocity of the satellite at which it is rotating around the earth. So we'll write the definition of orbital velocity. V0 is the velocity. V0 is the velocity at which satellites are moving. Satellites are rotating in an orbit around earth, or anything around earth, around a planet. We can say around a planet. Earth is a planet. So satellite v0 is the velocity at which satellites are rotating in an orbit around the earth. So what is the gravitational attractive force between these two bodies? G into capital M into small m divided by r square. Small m cancel, r get cancel. V0 is equal to root of gm divided by r. This is the equation of orbital velocity. Similar to escape velocity. What is escape velocity? We have learned at this point of time. Ve is equal to root of 2gm divided by r. So this is the escape velocity we have learned, just for your recollections. So this is orbital velocity, and this is escape velocity. Okay, so now what is the relation between these two? I know escape velocity equal to root 2 times of orbital velocity. Very important. Escape velocity is equal to root 2 times of orbital velocity. Important. Okay, so once you get escape velocity, you can find out orbital velocity. Once you get orbital velocity, you can find escape velocity by multiplying with root 2. Next, okay, we know G is equal to gm divided by r square. So gm equal to gr square. This we will substitute here, and we'll see v0 equal to root of gr square divided by r. V0 equal to root gr. V0 equal to root of gr, not only for g, both g and r within square root. So we have learned two important things. So orbital velocity root of gm by r, and escape velocity root 2 times of v0, and v0, the another equation, one equation is root of gm by r, another equation is root 0. Same equations we have learned for escape velocity, but what it is called, root of 2gr. Based on this also I can say root 2 into, what is root gr? Root gr is orbital velocity. We can also write in terms of this equation, or in terms of these two equations also we can write like this one. In terms of these two equations also we can write these things. Okay, so orbital velocity is a velocity at which the satellites which are rotating around the around Earth in a very simple way. Okay. Okay, so let's do one questions from the motion of the satellites area, and then we will see what's happening. Okay, so fine. Fine. A satellite, write the question. A satellite is revolving around Earth at a constant velocity, v, which means a satellite which is moving around the Earth at a constant velocity v. A body of mass m is ejected out of satellite, and it escapes out, means what? It is going, and it escapes out means what? It is going out of gravitational pull, and it is not coming to the gravitational pull. Okay, find the kinetic energy of that object at that instant. A satellite is revolving around the Earth at a constant velocity v. A body of mass m is ejected out of satellite and it escapes out. Find the kinetic energy of the object at that instance. Okay, so we have a mass m. We have an orbit will be here. A satellite which is rotating here will be at a constant velocity v. A mass which is throwing out with a velocity called escape velocity. I can say it's escape velocity because question is given, it is escapes out from the gravitational pull of Earth. Okay, then what is the kinetic energy of that object? So kinetic energy of that object is equal to half m into escape velocity squared. So half m into what is escape velocity in terms of this? What is the value of v in terms of v? It is root 2 times of v, because this v is the orbital velocity. So the object is throwing at a velocity of escape velocity. So escape velocity is equal to root 2 times of the orbital velocity. So root 2 the whole square. So which means 1 by 2 into m into 2 v square. So its kinetic energy of that object is equal to half mv square. You will have different options like this one, half mv square, half mv square, and you have the third options like 3 by 2 mv square. You have the fourth options like 2 mv square. Like this you have multiple options may come, and the answer to the question is mv square, because with respect to the velocity, satellite velocity is called orbital velocity, and the body is ejected from the satellite with a velocity called escape velocity, and that escape velocity is equal to root 2 times of orbital velocity called v. So we have the clear picture and we substituted there, and we got the answer to the question as mv square. Okay, this is quite important to learn about this stuffs, and yeah, well, see to the next one. Okay, we'll see the next one. Next topic is what we have learned now. Okay, orbital velocity. The next topic is time period of revolution of the satellites. Time period. Perfectly fine. We'll write it. Okay. So a orbit at a distance of a small r meter from the center. Okay. So what we have learned? We have a mass called m, and this is called Earth, and around this we have an orbit at a distance of r whose mass is m, and the body is rotating. So next heading is time period of revolution of satellite. Revolution of satellite. Satellite in the time period. Time period means what? Time taken to complete one rotation. So right, time taken to complete one rotation around Earth. Earth is a planet, around Earth. So time taken to complete one rotation around Earth. Okay, so we know time period is equal to distance divided by velocity. Okay, what is the velocity for a circle at a distance of r meter away? It is called 2 pi r, perimeter. That is the surface, that is the perimeter, that is the distance traveled, divided by what velocity will be here? Orbital velocity. So 2 pi r into root of gr. Okay, this is called the orbital velocity. So what will happen? So t is equal to 2 pi into, the r can be written as root r into root r. This can be written as root g into root r. So root r get cancelled. So you will get t is equal to 2 pi into root of r by g. This is an important relations to know. So time period of a satellite, t is equal to 2 pi into root of r by g in terms of r. Okay, t is equal to 2 pi into root of r by g. R is the height of the satellite from the center of Earth. If it is very closer to the Earth's surface, then small r is equal to capital R. So time taken by the satellite, time is equal to distance by velocity. So we have substituted the velocity of a satellite is nothing but called as orbital velocity, and we use that formula will be here to substitute it. Okay, and we substituted the orbital velocity formula we have given will be there. Here we have given root gr. Instead of giving that one, you can also use root of gm by r. This is also fine to use it. If you use this equation, sir, what you will get? 2 pi r into root of gm divided by r. Okay, so what you will get? 2 pi into r, this 1 by r, this root r will go to numerator, root r divided by root gm. Root r means 1 by 2. This is the power 1, so this is a power of 1 by 2. Okay, so what we can write after this one? So t is equal to 2 pi into r raised to 3 by 2 divided by root of gm. This can be also another equation in terms, if you are doing this one. So you have two options. You can substitute root gr, then you can go like this. And if you substitute a root gr, then you have to go like this. If you substitute root gr, you have to go like this. Root gr you can substitute one option. We have two formula, right, for orbital velocity, root gr or root of gm by r. Gm by r, if you substitute, you will get this equation. If you substitute a root gr, you will get this equation. Both equations are one and the same, but within different terms are used. G will capital G, here there is no capital G. Capital M will be here, here there is no capital M. Instead we have small letter g will be here. Okay. So two important concepts today we have learned. One is called escape velocity, one is called orbital velocity. With respect to, if you are looking to the previous year questions with respect to gravitation, escape velocity and gravitational and orbital velocity are pretty important, and you might get one questions out of these one by connecting the questions what we have learned so far. So please understand the concept very well and try to solve the questions whatever I have discussed in the sessions today along with the theory. Okay, hope you understood today's sessions. I'm stopping here and we will meet again with the next topic. So we have we have few more topics are left, well, only few, like some 20% portions are remaining, then we can close this chapters. Okay, hope you understand this concept very well. I hope you enjoyed and you get some new informations from me with respect to this chapter. So thanks for watching this video. Bye.